All right, so today we're diving into something pretty crucial in the world of web development. MySQLi transactions in PHP.
Oh, yeah. Transactions. Can't live without them when you're dealing with data, especially at scale.
Right. It's one of those things that can make or break your application's reliability.
Absolutely. It's all about keeping your data in sync, ensuring that if one part of a process fails, the whole thing fails gracefully.
And that's what we're going to unpack today. We're taking a close look at this guide from plus2net.com called, let's see here, Guide to MySQLi Transactions in PHP.
Plus2net, solid resource.
Yeah, they always have some great practical examples. So imagine this. You're building an e-commerce site, the works. Shopping cart, payment processing, order confirmation, the whole shebang.
A perfect breeding ground for potential data disasters if you're not careful.
Exactly. So someone's about to hit that complete purchase button. What's going through your mind as a developer?
Well, a million things at once, but top of mind, it's all about making sure the money actually leaves their account.
Right, because you don't want to end up with a situation where they think they've paid, but the order never goes through.
And on the flip side, you don't want them to be charged without the order being registered in the system. It's got to be this perfectly synchronized dance.
A delicate balance, to say the least.
Yeah.
And that's where transactions swoop in to save the day, right?
They're like the unsung heroes of data consistency, making sure everything happens in the right order or not at all.
Love that all or nothing. That really captures the essence of it.
Exactly. And that's precisely what Plus2net emphasizes in their guide, using the analogy of a bank transfer, which I thought was quite clever.
Right, because we've all been there, transferring money online. You want to make sure it leaves your account and ends up in the right place.
It's such a common scenario that everyone can relate to, but it really highlights the importance of this concept, even in our everyday lives.
Absolutely. It's like this underlying principle that most people don't even realize is running behind the scenes of almost every online interaction they have.
From booking flights to updating social media, transactions are the silent guardians of data integrity.
Okay, so it's clear they're important. But how do they actually work in practice? We're comfortable with MySQL, but walk us through how these transactions actually happen.
Sure. So MySQL gives you these tools, these methods that are built in, and they act like your transaction command center. You've got begin transaction, commit, and rollback.
Okay, so it's like we're talking directly to the database here, giving it specific instructions.
Precisely. With begin transaction, you're basically saying, all right, database, let's start a new transaction here. Everything I do from this point forward, treat it as one atomic unit.
So if even one tiny part of that unit fails, the whole thing gets scrapped.
You got it. And that's where our trusty rollback comes in. It's like hitting that undo button, making sure your database doesn't end up in some weird in-between state.
Now, I've heard this other term thrown around, TCL. Sounds a bit intimidating, like something out of a spy movie.
TCL, or Transaction Control Language. It sounds way fancier than it actually is. Think of it this way. It gives us even more control over these transactions, even more granular control over how they actually play out.
Okay, so more tools in our toolbox. I like it. What kind of control are we talking about here?
So we've got commands like commit to finalize the changes. That's like saying, okay, database, we're good here, make those changes permanent. And then there's rollback, which we already touched upon.
Right, the trusty undo button.
Yeah.
Anything else in our TCL arsenal that we should know about?
And this is where things get really interesting. We have save point. So think of it like checkpoints in a video game.
Okay, I'm intrigued. Tell me more about these checkpoints for databases.
All right, so let's stick with that e-commerce example we were talking about earlier. Imagine a customer adding items to their cart, applying a discount code, and then finally completing the purchase. Each of these steps, you could consider them like a save point.
So are you saying if, for example, the discount code doesn't work for whatever reason, we don't have to make them restart the entire checkout process?
Exactly, you hit the nail on the head. Save point gives you the flexibility to rewind to specific points in the transaction without scrapping everything. It's super useful for those more complex situations where you don't want to throw the baby out with the bathwater, so to speak.
That's amazing. It's like having fine-grained control over those changes to the database. But, okay, what happens when things go really wrong? Like really, really wrong?
That's where exception handling comes in, like a knight in shining armor. We use these try-catch blocks in our code, and they act like a safety net. It's basically saying, okay, let's try this operation, but if anything goes wrong, we have a backup plan ready to roll.
Sounds like having an undo button for those oops moments that inevitably happen when you're coding.
Precisely. And that backup plan usually involves our good friend rollback. which we talked about earlier. It just makes sure that any half-finished changes don't corrupt our precious, precious data.
It sounds like these try-catch blocks are like the guardians of data integrity, always watching over our shoulder.
They really are. It's always better to be safe than sorry, especially when you're dealing with something as critical as, data consistency.
Absolutely. So we've talked about these save points, right? Can you maybe paint a clearer picture for me? Like, when would you actually need that level of granular control in a real-world scenario?
Okay, so let's ditch the e-commerce example for a second. And let's say you're building a system that handles, I don't know, flight bookings. You've got seat selection, payment processing, ticket issuance, lots of moving parts.
Where lots can go wrong.
Exactly. So imagine someone's payment fails after they've already, gone through the process of selecting their seats.
Frustrating, right?
Oh, yeah, super frustrating. But I see where you're going with this. We don't want to roll back the entire transaction because then those seats might get booked by someone else in the meantime.
Exactly. You're on the same wavelength. This is a prime example of where a strategically placed save point, like right after the seat selection, would be an absolute lifesaver. You can handle that payment issue gracefully without, disrupting the entire flow for the user.
That makes a ton of sense. It's like you're giving users a smoother experience, even when things are going haywire behind the scenes. Right. And Plus TwoNet actually provides some great code examples to illustrate all of this, which is really helpful. They show how to use transactions for, like, those bread and butter database operations, inserting, updating, deleting multiple records, all that good stuff, all while making sure your data stays in tip-top shape.
Okay, so let's get practical for a second. Can you walk me through one of those real-world examples, like where this is absolutely crucial?
Sure. Let's say you're dealing with, I don't know, student records in a database, and you're adding a whole bunch of new students, like at the beginning of the semester. You wouldn't want a single student's data messing up the whole batch, right?
Right, that would be a nightmare to try to untangle.
A complete nightmare. So the code snippet in the Plus TwoNet guide shows you how to use a transaction for this. You begin the transaction, prepare your SQL insert statement, and then execute it for each student. If all the insertions go through, you commit the whole thing. But if any of them hit a snag, you catch the exception and roll back the entire transaction.
Okay, so it's like an all-or-nothing approach to inserting data. I'm definitely starting to see the power of this.
It's the same principle for updating or deleting multiple records, too. Think about updating everyone's grades at the end of the semester. You'd want all those changes to go through successfully, or if something goes wrong, no changes at all.
Yeah, it makes you realize how much could go wrong if you didn't have these safeguards in place.
It really does. Now, we've been talking about DML statements, insert, update, delete, but let's switch gears for a second and talk about their, let's say, less flexible cousin, the DDL statement.
DDL, right?
Yeah.
Refresh my memory on what those are again.
So DDL stands for Data Definition Language. These are the big guys that actually change the structure of your database. Think create, alter, drop. Powerful stuff.
Ah, right. But they don't really play by the same rules as those DML statements when it comes to transactions, do they?
You're catching on. And this is where things can get a little bit, well, tricky. DDL statements, they're kind of impatient. They have this implicit commit behavior in MySQL.
Implicit commit, what exactly does that mean?
So it means that the moment a DVL statement is executed within a transaction, MySQL is like, okay, we're committing everything up to this point, no going back. And here's the kicker. You can't roll back a DDL statement.
Wait, so if I accidentally drop a table in the middle of a transaction, I'm like completely out of luck.
That's the harsh reality, unfortunately. DDL statements, they're kind of like a bull in a china shop when it comes to transactions. You really have to be incredibly careful when you're using them within a transactional context.
Wow, okay, intense. It's like handling nitroglycerin. You definitely don't want to drop that.
Exactly. Great power, great responsibility, right? The Spider-Man rule applies to database management, too.
Duly noted. I'll be treating those DDL statements with the utmost care from now on.
As you should. But on a lighter note, have you ever heard of nested transactions?
Nested transactions. Sounds like we're going deeper into the matrix here.
In a way, we are. While MySQL doesn't technically support nested transactions, like, in the truest sense, there's a clever workaround.
Oh, I'm all ears.
Remember our trusty save points? Well, it turns out you can strategically use them to mimic the behavior of nested transactions by setting and managing save points within a larger transaction, you can kind of create these isolated blocks of operation.
So it's like having these smaller self-contained transactions within the main one.
You got it. It's a bit of an advanced technique, but it's incredibly useful when you need that super fine-grained control over those complex database operations.
It's like having multiple layers of safety nets. You've thought of everything. It
Yes.
really is. It's like we've gone from zero to hero on database transactions in like, what, 20 minutes?
Time flies when you're talking data, right?
It really does. But even with all these fancy tools and techniques, you still need to know how to use them effectively, right?
Absolutely. You can have all the fancy tools in the world, but if you don't use them wisely, you can still run into trouble.
So what are some of those like golden rules, those best practices that we should keep in mind when we're working with transactions? I don't want to accidentally bring down the whole system.
Right. So rule number one, and this is crucial, keep your transactions as short and sweet as possible.
Short and sweet, like a good pop song.
Exactly. The longer a transaction runs, the more resources it's going to hog up, the higher the chance of, creating bottlenecks. It's like, imagine a line forming at a busy intersection because one car is taking forever to turn,
Right.
right? Not good.
Definitely not a good look. So it's about being mindful of like other processes that might be waiting in the wings.
Precisely. And another crucial best practice, and we touched upon this a little bit earlier, is to handle your exceptions, like religiously.
Those try-catch blocks.
Exactly. They're your best friends when it comes to keeping that data squeaky clean. It's like having a safety net to catch any of those errors before they spiral out of control.
And strategically place save points too, right?
Yes, our trusty save points. They can be a real lifesaver, especially in those, more complex scenarios, but a word of caution. Too much of a good thing can sometimes backfire. Too many save points can actually slow things down, impact performance.
So it's all about finding that balance, that sweet spot between flexibility and efficiency.
Exactly. Oh, and here's another pro tip for you. Never, ever hold transactions open while you're waiting for user input. You don't want to be holding your database hostage while someone's off making a sandwich, right?
Right, right. Get all your ducks in a row, gather all the necessary information up front to keep those transactions nice and snappy.
Precisely. Keep them short, sweet, and to the point.
I like it.
Yeah.
So to wrap things up, we've covered a ton of ground today, from the basics of MySQL transactions to like mastering the art of save points and even navigating the, let's say, exciting world of DDL statements.
We've been on quite a journey.
We have. Any final words of wisdom for our listeners as they embark on their own database adventures?
We've been really focused on MySQL and PHP today, but the truth is a lot of these principles that we've been talking about, they apply more broadly too. Transactions, the ACD properties, error handling, these are like universal concepts in software development. They're all about building reliable, robust applications no matter what language or system you're working with.
I love that. It's like the more you learn, the more you realize how much these fundamental concepts connect everything together.
Exactly.
Well, on that note, a huge thank you to our expert for, demystifying the world of MySQLi transactions. You've given us a lot to think about.
My pleasure.
And to all of you listening, thank you for joining us on this deep dive. Until next time, happy coding.